couple years ago, I created a unicycle riding skeleton for a carnival-themed Halloween display. It looked pretty good from the ground, but the Rube Goldberg-type mechanics I used for the prop required constant attention and resetting. The biggest problem was the motorized spindle I used to move a cart back and forth on a hidden track. Even though the string attached to the spindle didn't stretch, there was constant slippage, causing drifting in the cart's starting and stopping points. If I rebuild the prop, I need to replace the spindle and string with something more reliable. Recently I learned about two things that could be used to create a better means of locomotion for the prop. The first is this ribbed timing belt that I could use to create non-slip traction between a motorized wheel and the track. As an experiment, I glued a length of the timing belt to this wheel. The red rubber band held the belt in place while the glue dried. Then I stapled another length of belt to a wooden rail in the center of a short test track. For the test, I screwed L brackets under the cart to keep the cart centered on the rail. I'd replace the brackets with sideways wheels in a final version. The wheel was attached directly to a windshield wiper motor that was in turn attached to the cart. As with the original setup, the motor is controlled using a picovolt. A picovolt from Fright Props is great because it allows you to control the speed and direction of a motor or a linear actuator, and even better, it allows you to record a sequence of motions, actually two sequences, that you can play back using a trigger of some sort. The second thing I learned about to make a better prop are magnetic triggers. The picovolt has inputs for two triggers like push buttons, motion detectors, or pressure mats. I'm going to trigger the forward and backward sequences using magnetic triggers. I'll have two triggers on the cart, and one trigger will pass over a magnet at one end and trigger, like the forward sequence, and then when the cart gets to the other end of the track, the other trigger will pass over another magnet and trigger the reverse direction. Back and forth, back and forth. So that way the cart never runs past where I want it to run. So there's the cart running in the one direction. It passes the magnet on the left, so it reverses direction using the reverse sequence. Passes a magnet on the opposite side, so that triggers the second sequence. And the cart will keep going forwards and backwards and forwards and backwards until I click the picovolt and make the sequence stop entirely. And the sequences can be more complicated than just forwards and backwards. It's whatever you want to program in with the direction and speed control wheel. So, if I create another unicycle riding skeleton, the motion will likely be based on a setup like this one.